in Aaron's little circuit, he's got it looks to me on the diagram like he says 2.1K, a 2.1K resistor in the input 9-volt power line to the 555 timer. The 555 timer is being operated at an insufficient voltage for it to make a real square wave. The MOSFET is not oscillating, the 555 timer is oscillating, and the MOSFET is amplifying that oscillation. It's doing just exactly what you're telling it to. It's not a scope triggering problem like I thought at first. It's the 555 timer, because the 555 timer is not being given enough. Look at that. The 555 timer is not being given enough voltage to actually create a good square pulse. And so the MOSFET is it just ain't doing its thing. I mean, I can get traces from the MOSFET, certainly. See there? But all of that weirdness, here I'm changing the scope's trigger level here, and I can't get my scope to trigger on that weirdness either. Or can I? Ooh, look there. Caught it. But that's what it is. It's the 555 timer not getting enough actual voltage to make a good pulse to drive the MOSFET. And I'll prove that to you by leaving all of the settings the same, and I will just take the resistor out. And I'll put the positive lead of the battery over here where the resistor was, like that. Now, and voila. Nice square pulses on the B. Where'd the A go? There we go. There's A. Oh, come on. See that? That's because, once again, the 555 timer is being operated outside of its proper parameters. So I'm looking at the Ainsley points just as we were before. So if I turn that gate MOSFET or gate drive resistor all the way up, let's see. That's the B trace, that's the current input. There I'm varying the 555 timer pots. That's the A trace, the response of the MOSFET. There I'm varying the 555 timer pots. Alright, I'll put both traces on. I'll change this is the inline pot to the MOSFET on the gate. Turning it down and 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 down. Ooh, look, eyeglasses. Down and down and down. That's all the way down on that pot with enough voltage on the 555 for it to operate sort of properly. But this is the worst circuit you could possibly choose to drive a MOSFET with, because the 555 is operating in a very, why do you think they call it astable? It's in the astable mode. Okay, so the reason that the MOSFET was misbehaving, and you think that's a bad trigger? No, it's a perfectly good trigger. It's just we've run the frequency all the way up. With these controls on this 555 that Aaron is using, you have a really wide range of frequency, but not too much control over the duty cycle. You can get fairly short duty cycles, but only by changing the frequency. Okay. So, if I put that resistor back in, where did it go? There it is. You come here, you little resistor. If I put that resistor back in the circuit, like that, just stick this over here someplace, like that, and then plug the battery in so that we're now the resistor is in series, and go back over here. Now I got to turn the gate. Now you see those tiny little peaks there? Those are the 555 pulses that we were looking at before, I haven't changed any potentiometer settings. That's all you get with that big resistor in line. Now I'm going to start changing some pot settings. And looky there. There's that misbehavior. There's that misbehavior. That's because the 555 timer is not getting enough voltage to function properly. And so the MOSFET is trying to match those oscillations. And if you're not very good with your scope triggering system, or if the scope gets confused, it loses that trigger. But you can usually get it back. That's my diagnosis at this point. Insufficient voltage to the 555 timer because of that inline resistor that Aaron is using. Okay, thanks. That's it.